All right, good afternoon or good morning. It's the last day of notes, ladies and gentlemen. Congratulations, we made it. All right, we have 12.6 talking about similar solids here. We have talked about scale factors before. It's been a little while, but we can use scale factors to help us find surface areas of similar figures, surface areas and volumes of similar figures. And so it turns out to be really quite handy. Scale factors refer to a length unit, like inches or feet or yards, or a radius. So these are a single length unit, a linear unit. And so we talk about that as the A to B. How do they change? And we might write it A to B like this, or maybe we write A over B. Either way would be fine, but we want to make sure that we reduce those ratios. And if we want the surface area, well, area is just squaring the length units. And so if we have surface area, we're going to just make sure whatever our A and B scale factor are, that we just square those scale factor ratios. So we might write it A squared to B squared, or I'm probably going to stick with A squared over B squared. And volume is, of course, cubic units. It is these scale factors cubed. So A cubed to B cubed, or I might write it A cubed over B cubed. And so we're going to use a particular ratio based on what we want to find or what we want to do. It's important that we remember we always want to reduce our ratio, reduce first. And then if we have been given surface area or volume ratios, we need to reduce and get back to the scale factor first. We always have to go back to the linear unit before we do something else. All right, so let's try some examples here. If the cones below are similar, what is the ratio of the surface area of the larger cone to the surface area of the smaller cone? So you can see we have the larger cone and the smaller cone, and they're giving us a slant height here, a slant height of 28 and a slant height of 8. We want to go from the larger cone to the smaller cone. That's what it said. And so they're telling us that they are similar, and these are the length units. So they're going to help me find my A and my B. So I'm just going to do 28 yards over 8 yards. And those are linear units. I'm going to reduce that. Both of these divide by 4. Divide by 4. Divide by 4. So 28 divided by 4 is 7, and 8 divided by 4 is 2. Of course, you can use your calculator. 28 divided by 8, get a decimal, and then math bracket, we get 7 halves, okay? So however you do that. These, because we started with linear units, these are going to give us our scale factor, A and B. So this is A over B, which means the A is 7 and the B is 2. So what it's asking for, it wants the ratio of surface areas. So now that we have our A is equal to 7 and B is equal to 2, I can find the ratio of the surface areas because I just need to use the surface area ratio, which just squares those units. So that's just going to be A squared over B squared, which is going to be 7 squared over the 2 squared, so 49 over 4. And that's the ratio of the surface areas of each of these cones. Well, the surface area of this is 49 times 49 fourths bigger than this one. So kind of interesting. All right, let's look here at number 2. Again, they are giving us pyramids are similar, and they are giving us length units here. The 16.5 meter base for the smaller pyramid and 22 meter base for the bigger pyramid. So I'm going to start with that. Those are regular old linear units. We want to find the volume the ratio of the volume of the smaller pyramid to the larger pyramid. So we're going to go smaller to larger. So I'm going to start with my 16.5 smaller length over the bigger length, 22. And again, I'm going to reduce that, 16.5 over 22, 75, which reduces to 3/4. And so what that is giving me is my scale factor. That's going to give me my A and my B. So my A is equal to 3 and the B is equal to 4. Now it wants us to find the ratio of the volume. So volume is going to be cubic A's and B's. So to find the ratio of the volumes, it's going to be A cubed over B cubed. So 3 to the third over 4 to the third. 3 cubed is 27 and 4 cubed is 64. So that is the ratio of the volumes of the two figures. All right. Let's look at number 3 and 4. All right, on number 3, if the cylinders are similar, what is the ratio of the radius? Oh, now we want to get back to radius. That is just the length of the radius. The radius of the larger cylinder to the radius of the smaller. So we want to go larger to smaller. And when I look at what they're giving us here, they're giving us surface area is 116 millimeters squared and surface area is 29. So I have to start now, because they gave me surface area, they're giving me the squares of A and B. So I have to go know that A squared over B squared, because they gave us surface area. So larger to smaller, so we're going to do 116 over 29. Again, I want to reduce, I'm going to use an arrow, not an equal sign. I want to reduce this fraction, and boy, is that ugly. I have no idea what 116 over 29 is. Oh, it turns out to be 4. Divided evenly. How about that? So 116 divided by 29 is 4. So it becomes 4 over 1, if you will. This is telling me that A squared is equal to 4 and B squared is equal to 1. And so what we need to do before, is figure out what the A actually is. So if A squared equals 4, then I'm going to go ahead and take a square root, and I get that A equals 2, and B squared equals 1. So again, we're going to take a square root of both sides, and it turns out that B equals 1. Square root of 1 is 1. And so it's asking, what is the ratio of the radius? Well, radius is a linear unit, so they're just looking for that linear length, and the ratio would be A over B. So A over B would just be 2 over 1, and that's what they're looking for there. Ratio of a linear length. Let's try number 4. On number 4, they have given us volume. They are similar prisms. What is the ratio of the height? So again, we just want the heights. And again, those are linear. So we, again, are trying to just figure out the A and the B, just like on the last one. But we're starting with volume information. So volume is our scale factors cubed. So the volume, to figure out the A and the B, we're starting here with these cubic A's and B's because they gave us volume. And we want to go the ratio from the smaller to the larger. So smaller to larger, so smaller's on top. So this is going to be 15 over 405. And again, I don't know what that is. 15 over 405, math bracket. And so that cleans up to be 1 over 27. And again, that's telling us what A cubed is, and it's telling us that 27 is B cubed. So again, A cubed equals 1. How do I figure out what A is? Well, we could take a cube root if we want to, but A is just 1. 1 cubed is 1. And then for the b, we know that b cubed is 27. So again, if we wanted, we could figure out the cube root. And again, that's under the math menu on your calculator. But the cubed root of 27, what number cubed is 27? 3. So the a is 1 and the b is 3. So it turns out if we want the height, that is just a linear unit, the ratio would be a over b. So that's going to be 1 over 3. Which is kind of interesting. All right. The pyramids below are similar. What is the ratio of the volume? Ratio of volume is what we're looking for. The smaller pyramid to the volume of the larger pyramid. So once again, they're giving us starting information that is just surface area. Surface area is square units. That is going to be a squared over b squared, since we're talking about area. And again, I have to get back to the original a and b before I can do anything else. So smaller to larger, so small to large, so small first. 52 over 325, let's see what that reduces to, is 0.16 math bracket, and I get 4 over 25. So that becomes 4 over 25. And again, 4 is some number squared, and what number squared gives you 25? Oh, a must be 2 and b must be 5, because 5 squared gives you 25 and 2 squared gives you 4. So now I know my a and my b, and if I want to find the ratio of the volume, now then I would want to do, hey, what's a cubed over b cubed? Because that's going to give me the volume ratio, just taking that scale factor and cubing it. So 2 cubed over 5 cubed, that's going to be 8 over 125, and that is the ratio of their volumes. Okay, kind of interesting. Now, let's actually do some. This is very much similar, number 6, but let's go on and try number 7. So number 7, now we're going to figure out how to use those ratios that we can find to actually figure out the volume of something, which is pretty useful. All right, the ratio of diameter. So diameter is a length unit, like 8 centimeters or 8 millimeters. So that is a length unit. So this is going to give me my a and my b, my scale factors. So the ratio of diameters of 2 similar cylinders, it's important that we know they're similar, is 3 to 5. If the surface area, I'm going to write that down, the ratio of diameters, so they're giving me the a and the b. So that ratio is 3 to 5. If the surface area of the smaller cylinder is 378 square inches, find the surface area of the larger cylinder. It's all very interesting. So we have this scale factor, and I have information about surface area. So what I need to do is I need to figure out how this is going to scale to become surface area. So surface area, I'm going to use a squared over b squared. So I'm going to take my 3 and I'm going to square it. I'm going to take my b of 5 and I'm going to square that. That's going to be 9 over 25. So this is the scale factor for surface area. So that is 9 over 25 is the ratio of their areas. And the smaller cylinder is 378 square inches. So I'm going to have another ratio here of a smaller to a larger cylinder, surface area. So I have 378 square inches, and I want to find the surface area of the larger cylinder. And I'm just going to call that L for larger. You'll notice I put the L on the bottom because it has to match up with the thing that's larger. 378 is smaller, so it's matching up with the smaller surface area ratio. And how do we solve these things? We cross multiply.
Okay, sorry about that. My computer just went to sleep. Okay, here we go. All right, so we are going to cross multiply. 9 times L is 9L, and 25 times 378 is 9450. And then I need to divide by 9. And I get 1050. So L equals 1050. And so that is the surface area of the larger cylinder. So that would be inches squared. So the larger cylinder is 1,050 square inches. Let's try another. All right, the ratio of surface areas. So surface areas are things that are squared. So this is going to give me a squared over b squared, because they are talking about the surface area ratios. Of two similar pyramids is 16 to 9. So 16 to 9. And again, in order to use this, I always need to get back to the a and the b. So this is saying that a squared equals 16. So what number squared equals 16? That must mean that a is 4, because 4 squared is 16. And what number squared gives you 9? Well, 3. 3 squared gives you 9. So now I know my a and my b. And what I'm going to do with that, it says, if the volume of the smaller pyramid is 297 centimeters cubed, find the volume of the larger pyramid. So I need to use a volume ratio. My volume ratio is a cubed over b cubed. So my a cubed would be 4 to the third. And my b cubed would be 3 to the third. 4 cubed is 64. 3 cubed is 27. So I'm going to use this ratio to help me find my volume. 64 over 27 is going to be equal to, let's see, the volume of the smaller pyramid is 297. So in my ratio, where should my smaller thing go? Should match up with the smaller number, 297. And we want to find the volume of the larger. It's going to match up with my larger number. So I want to find the larger volume. Once again, we're going to cross multiply. So I have 27 times L equals 64 times 297 is 19,008. 19,008. And if I divide by 27, I get 704. So L equals 704, and these are centimeters cubed. The larger pyramid has a volume of 704. So this is kind of nice. We don't actually have to see the larger pyramid. We can just use these ratios to help us find the volume. All right, let's look at number 9. The prisms below are similar, very important. Find the value of x. So when I look at this figure, x is just a length, all right, a length unit, and 20 is just a length unit. So I need to figure out that x, which the only other information they're giving us is that we know their volumes. We have the volume of the larger thing is 840. and we have the volume of the smaller thing. So I'm going to use this information to help me figure out my scale factors. So starting with my volumes here, I know that volume is cubic scale factors. So I'm going to use that. Let's see. So starting with my larger, I have 840. And my smaller one, or whatever, it doesn't matter, 105. I'm going to reduce that. Let's see, 840 divided by 105 is 8. Oh, that cleaned up really well. So we get 8 over 1. And so this is telling me that some number cubed is 8 and some number cubed is 1. That must mean that A equals 2 and B must equal 1. 2 cubed gives you 8 and 1 cubed gives you 1. Now I need to find the value of x. So I have a length here that's 20 and I need to find this other length that's clearly smaller for x. So I'm going to do just my regular old A and B because I want regular length, nothing fancy. So I'm going to do my A over B, which is 2 over 1, is equal to my length over a length. And again, I want my bigger length of 20 to match up with my 2 because it's bigger. And my x is going to go on the bottom there. And I'm going to go ahead and cross multiply. So 2 times x is 2x equals 20. And then divide by 2, I get x equals 10. So the length of that piece of our prism is 10 centimeters long. Put centimeters here. All right. Almost done. One more. Cone A and cone B are similar, and the surface area of cone A is 108, and the surface area of cone B is 147. So since we're using surface area, I'm thinking about A squared over B squared. Since they gave me surface area, that's how we could look at the ratios. So that's going to be 108 over 857.5. Oh, no, just kidding. Oops. I read the wrong thing. 108 millimeters squared, and the surface area cone B is 147. I was looking at the wrong spot. Okay. So those are our surface areas. I'm going to reduce those. 108 over 147. And math bracket, I get 36 over 49. 36 over 49. And so again, that is saying some number squared is 36 and some number squared is 49. So that means A must be 6. 6 squared is 36. And B must be 7. 7 squared is 49. So that helps me get my A and my B. But they want us to find volume. In order to find volume, I need to cube my scale factors. So I need A cubed over B cubed. 6 to the third power is 216. So 216. And B cubed, 7 to the third power is my favorite, is 343. Go. All right, so 343. So that gives me my ratio of volumes. And it says the volume of cone B, if the volume of cone B is 857.5, find the volume of cone A. Let's see, I put A on top. So we want to figure out cone A, and cone B was the second thing we were talking about, and that number was on the bottom. So I'm going to put cone B. The volume of cone B is 857.5. Right. So there's the setup for that. I'm going to go ahead and cross multiply. So 343 times A, and then 216 times 857.5 is 185,220. And then divided by 343. I get 540. And that is the volume of cone A, so millimeters cubed. Okay, so hopefully you can use this to answer your worksheet questions and find volumes and surface areas of similar figures. All right, thanks everybody. Yay, we're done, hallelujah.